To begin the panel, I want to ask a question related to the primary challenges in scaling and proving infrastructure for ZK protocols. How do your projects address these challenges?
Okay, yeah, probably like I can go for first. Yeah, so like Cysic is like doing like a hardware software combined approach to address the concerns in the proving infrastructure. So right now we are relying on like a lot of like GPU to do the proving for like our customers. Like for instance, like in the past several months, we have generated like more than 7 million proof for the ZK community. And we are right now also developing our own hardware, which will like achieve the real-time ZK proving. Like for instance, like we can use like our hardware to our like own ASIC chips to prove like probably like more than 500K keycheck functions per second, and this like hardware can like make it like like more accessible to the community, and we can also use the hardware to achieve the verge approach like from Vitalik. Yeah.
At Marlin, we are building a proof market called Calypso. And Calypso is basically a marketplace that lets you outsource proof generation to a third-party network of like provers instead of doing it yourself, right? And the broad vision is basically to get the optimization flywheel going for ZK. So given the market size in ZK today, you can probably justify a certain amount invested into like optimizations and like getting better hardware and stuff like that. And once you have better hardware, essentially your proofs are faster, which means your user experience gets better. And hopefully that's sort of like grows your market to a point where you can justify investing a lot more into ZK, right? So it's a real positive feedback loop that we've seen in like the mining ecosystem with like Bitcoin and Ethereum. And our goal is to basically get the same flywheel going for the ZK ecosystem.
Okay. Hello, everyone. I'm Jiannan Ouyang, co-founder and CEO of Snarkify. We are building a high-performance proof network for end-to-end proving for ZK rollups. I'll start with something spicy. I don't think once you have better hardware, you automatically get higher performance proof systems. That does not happen automatically because we have to look at this problem end-to-end. You have the software part, you have the hardware part. Even if you build a very fast ASIC, or even we have faster GPUs from NVIDIA, there are still a lot of memory bottleneck, data communication from the CPU side and the accelerator side that would become the bottleneck, so that faster compute does not help. So we took an end-to-end approach. By end-to-end, I mean we have a GPU DP network, which handles the hardware supply. We also have a GPU acceleration layer where our in-house GPU software, we're quite strong on GPU acceleration. So instead of betting on ASIC or FPGA, we are heavily betting on GPU. We are probably we are probably the best GPU team in ZK because we have won many of the Z-Prize hardware accelerations. And on top of that, we also have our ZK research team working on proof systems and ZK VMs, trying to figure out how to design proof systems and ZK VMs such that they can run efficiently on GPUs. So that's our take. Thanks.
Hi, everyone. This is Norbert from Gevulot. Basically, we are building the first universal ZK infrastructure, ZK optimized infrastructure for the space. And I think regarding the question and challenges to scalability, I think fragmentation is one of the key challenges, and we are trying to solve that by making building a protocol that's universally supporting any proof system out there. You can use the pre-deployed ones, or you can deploy your own prover and generate proofs efficiently. The other thing is, I think, a challenge to scalability is centralization. Many of the teams currently out there, specifically many of the L2s, are actually doing proving in a centralized fashion. Idle time actually burns a whole lot of money. Hardware utilization is not optimal in those cases. So we are building a decentralized protocol to address that, to make proving basically fast, cheap, and truly decentralized. Yep, that's my take.
Awesome. Variety of experiences and different directions in terms of where you see the different projects headed. I noticed there was a question or an answer by by Dr. Ouyang related to the hardware, what role hardware plays. Do you, I guess starting with Norbert, what role, I would say, like, would Gevulot, does Gevulot play within the hardware optimizations, or how do you see that within the prover marketplace?
Thanks. From our side, basically, we are kind of hardware agnostic. Currently, we support CPU and GPU proving as well, but we are building our platform to support also any exotic hardware out there. I mean, I guess it's more for Cysic, more for Leo to answer, but I've seen some recent benchmarks from Fabrics VPU, about Fabrics VPU, like 5.5x increase in performance on RISC-V cycles compared to 4090s, or 11x compared to 3090s. So we are looking to support any of the exotic hardware out there and support prover node operators with such hardware as well. Yeah, I think it's exciting to see whether, as Dr. Ouyang mentioned, GPU proving is going to be the mainstream, or like exotic hardware takes off. Curious to see that.
Yeah, that's a very actually interesting question, and there's not a clear answer yet who will win in the long run. But I think our position is that we are here to make the GPU performance baseline as high as possible, so that it's very hard to beat by any other hardware accelerator. So we are the baseline. So no matter what kind of hardware you're working on, ASIC, FPGAs, you have to beat our GPU performance. I think people haven't seen the full potential of GPU performance yet. For example, from the most recent Z-Prize end-to-end proving result, actually judged by Leo here, one of my co-founder, Niall Imart, was one of the best GPU acceleration guru in ZK. He actually achieved 900 times speed up for end-to-end Planck proof on a single GPU device. Well, this number sounds high and mind-blowing. The reason is that all the compute are put on the GPU for that particular problem. There's no communication between the CPU and GPUs. So the learning there is, once you can design a proof system such that you can eliminate cross-device communication, you can actually achieve very high performance. This is true for both GPU and any other accelerators, because once you are bottlenecked on the memory communication or on the GPU side, no matter how fast your accelerator is, it's not helpful because it cannot saturate the compute. So I think both, like all the hardware accelerator companies are facing the same problem, which is how to design an accelerator-friendly ZK proof system. Yeah, thanks.
So as a proof market, we don't really have to take calls on which hardware will win out, because like the market doesn't really care about how you generate the proof, right? All it cares about is that like you have a valid proof and it verifies. So for us, the hardware doesn't really matter. What's important is that the marketplace is like competitive. So what that means is there's really an incentive for people to sort of like invest in creating better hardware, like hardware that's more optimized to specific proof systems or like specific projects, and we get to like onboard that onto the market, right? But personally, the trend that I've been seeing in the ZK space is the move towards sort of like hybrid systems, where a lot of systems today use a combination of like IPA, PCS, maybe some checks here and there. So building hardware for like an ever-changing system that seems to be accommodating more and more pieces of the ecosystem into like a single protocol is honestly quite hard, because you quickly run into like what's called the Amdahl's law, right? So the more you optimize one component, the less important it becomes, because all of the other components end up taking the rest of the time, right? We've already seen this happen with like MSMs and entities. We had a lot of ASICs come out that like speeded up MSMs and ASICs and all that. But the bottleneck has slowly moved on to like PCS and Sumcheck and all that, right? So yeah, building hardware at this point might be a little early in my opinion, but yeah, let's see where it goes.
Okay, yeah. So like I'll like talk a little bit about like our opinion on the hardware part. So like the ZK proving hardware is basically like very similar to Bitcoin mining. Like in Bitcoin mining, like you started like using like CPU, then you jump to FPGA or like or GPU, then announced like there is ASICs coming from like Bitmain. So like in hardware, like there are like basically like probably like two metrics, like performance per dollar and also performance per watt. The first performance per dollar means like how much you need to pay for your hardware. Yeah. So and the second is like performance per watt, which is like how much you need to pay every day to run this hardware. Yeah. So like when like Cysic like designing the hardware, we always have these like two metrics like in mind. We just want to build them. Like our main competitor is basically like a NVIDIA GPU, and we want to have at least probably like one order of magnitude better performance, like in terms of uh, these two metrics. And also, so that's something like of our like design principle. The second part is about probably like yeah, as a panelist mentioned, like there is always some change in the ZK proving part. It's not as finalized as like the Bitcoin mine. So so the real challenge right now is to say we need to design a hardware that's like general enough to cover as many possible proof backends as possible, but still within a reasonable budget since we are just a startup, we're not big. For that way, like you need to like have some like clever design on the hardware to make it like general enough to cover this like code-based, hash-based, or like curve-based proof system. Yeah.
That's a good point relating to the cost of proving as well as the speed, and what's to best optimize for the structure today. And actually, a follow-up question to that: is there enough proof demand for where this type of proving structures that you're designing? Are you optimizing for maybe things that are more cost effective today, and then later on we'll scale with demand? What are your trajectories looking like? And then we'll start with Leo.
Yeah. So like I think it's also building like a Cysic network, which is a ZK proof and also verification layer. And in the past, I guess 4 or 5 months, we have generated more than 7 million proofs for the community, and it's basically like coming from like several like big players. We are right now like expanding like our support for more customers in the ZK space. Yeah, since like Cysic like well connected with the mining community, so basically we can have like as many GPU as possible if we want. Like for instance, like in ADO mining, we have like more than I guess like 50,000 GPUs like enjoying, and if we can like have like more ZK customers, which right now we're exploring, so probably like we can I guess the demand is still like high enough to at least make a lot of like players in the community to survive. Yeah.
So personally, I don't think we are there today, but we are getting there. And there are like three main areas that I see us growing towards there. One is, of course, like ZK proof of work mining, as Leo mentioned. Just due to its very nature, proof of work can basically take as much hardware as you can throw at it, right? So it's almost like an infinite demand hack in that way. On the other side, we also have a lot of applications starting to use like ZK VMs and like onboarding like Snarks and Gnahack and all of that into their core protocols, right? So applications are also like a really fast like growing sector because again, there's no real like limit for the number of applications that you're going to have or like the number of ZK proofs that they're going to need, right? And I'm not that confident whether the roll-up segment will be that big. But yeah, seems like rollups also need a lot of compute space currently, as I'm guess Norbert will watch for it. The ASIC proven it is like slated to require something around the order of like 1,000 nodes per proven network. So yeah, depending on like how many rollups there are and like how intensive each of these rollups are, we might see like quite a bit of demand from that as well.
Well, our observation that short answer is there are a lot of supply of compute, either GPU or any other devices, but there's not enough demand yet. But we are seeing increasing demand. We are very opinionated about what kind of workload we care about. We don't claim to be a universal proof generation provider. Right now, we are particularly focused on block proving for ZK-ROPS. In the past 1 year or two, we have worked with ZK-ML companies, co-processor companies, maybe ZK Bridges companies, as well as ZK-ROP companies. And one thing we figured out is that ZK-ROPS is only ZK workload right now that can provide you volume. Like as a proving service provider, we care about large volume of proof generations from paid customers. I think right now those ZK-ROPS are the larger ones. And also, many of the ZK-ROPS right now are running on public cloud, AWS, GCP. Some of them have decentralized their prover infra. Some of them are decentralizing their infra right now. I think we're seeing the demand to open up so that like prover networks like us could have more potential proof demand. That's our take.
From my side, I think I agree basically with all of you guys. We are also very much focused, like short term, the demand is definitely coming from L2s and rollups. It's interesting to see the dynamics in terms of their decentralization paths. And I think there will be a tipping point there pretty soon. I would say maybe a couple of months where some reliable solutions occur, reliable providers, and all the rest of the industry is going to start opening up like in an increased pace. But another thing is that we are looking at heavily is OP seemed to have been winning, like the optimistic stack, not particularly optimism, but like the optimistic stack. And as we see like OP succinct or, I don't know, risk zeros, Zeth proving Ethereum, or I don't know, many other proof systems or provers coming online with the aim to provide real-time proving. I think proving of L1s, optimistic chains transitioning to ZK is a very valid like next round after we have some mature infrastructure in place. And that's what we at Gevulot are working toward.
That's a common theme that I hear is that the L2 space is the one that is supplying the most demand, I guess. But not all L2s that I'm aware are currently using, I guess, like or outsourcing their proving infrastructure. Sometimes some of them are leveraging, you know, their own types of proving infrastructure. What would you think would be the key the key value proposition that will get these L2s to transition over from locally or from proving their running their own provers to now outsourcing? And I guess we'll start with you, Norbert, if you want.
Okay, thanks. Well, I think what I see is that many of them have been and to learn from the mistakes maybe others are doing in their first steps. But jokes aside, I think as I mentioned, as the landscape matures, as the infrastructure, the proof providers mature, we had the STAC contest in August, September, which was basically the first decentralized proving, like live decentralized proof outsourced, proving outsourced in the space. I think with that, it largely kicked off a bunch of initiatives and started like minds opening up towards decentralization. I think the cost factor is going to be big because it's one thing that is hindering like decentralization and like also demand coming in is the cost of proving. Like I think there are a bunch of applications out there who would love to become verifiable, but it's just too expensive yet and it's not economically viable. what we are looking to do, and it seems to be absolutely realistic, is to decrease the cost of proving by at least an order of magnitude. With Gevulot, we see our economics, how it's working out, and you don't even need an auction for that. We are baking it into the protocol, so it's available for anyone. And as soon as the cost of proving is small, and you are able to provide an available network, a scalable network, and you also remove the idle time from the users, then they will start thinking, okay, proving is cheap and I don't waste money with idle time. And that's what many of the centralized setups with roll-ups proving with their own infrastructure are currently facing now.
Yeah, I'll second that. I think short answer is cost. They will open up their proving infra, because otherwise they will not stay competitive because other people are moving into cheaper proving solutions. If we look at the OP operation cost, if you want to launch an OP chain, it probably costs you $2,000 per month from the REST providers. However, if you launch a ZK chain today using any of the open source, open ZK stack solutions, it costs you maybe 20 times more than that, 40K per month. So how to get the cost down? The first step is to move your proving infra out from the public cloud. So the off-cloud GPUs are 10 times cheaper. Maybe ASICs are even more cheaper than that. The second step is to build more efficient software proof systems so that given the same hardware resource, you can prove more stuff with a shorter amount of time. With these two in place, we can drive the proving cost down dramatically. And I think this will happen soon in the next, at least like moving out of public cloud part could happen in the next 3 to 6 months. We'll see how the proof system evolves in the next year, but it looks very promising. Yeah.
Yeah, I would agree with all that. I think I should also add that at the end of the day, it might not matter much as to how rollups really want to do their proof of sourcing and all that. Because it seems like at the end of the day, all rollups want is just somebody to place a bond and say, hey, I'm going to generate a proof for this block, right? Beyond that, for one, they don't really care. And number two, there's no really a good way for them to enforce that their validators don't actually use a proof market, right? So yeah, end of the day, rollups for one, they seem to be agnostic about proof markets. Like if you want to outsource that, it's fine. But at the end of the day, they might not even have a say towards that.
Oh, yeah. Oh, okay. Yeah. So from like Cysic's perspective, like I think like there are just the two factors. Like the first is the performance, the second is the cost. And if you can help your like recall like the ZK project, they're just the customers. They want to generate their proof as fast as possible as like very probably like as little cost as possible. So that's like what Cysic is doing. Like, for instance, there's like a new customer like coming to like Cysic network, and we can basically reduce the proof generation time for them at least to 1/3 or like even 1/4. And we do it at we do it at the same price or even like lower for them to do the ZK proving. So like if you have like advantages over these two factors, then you can like win in like more customers like from the ZK community, I think.
Perfect. No, I like the variety of perspectives, but it all boils down to the cost, the speed, the liveness as well. So making sure that the proofs are posted at specific times, to have those finality guarantees, and definitely good directions moving forward in terms of the customer-facing approach. And I guess in terms of when we talk about the decrease of proof costs, how are your projects, attempting that, to be competitive? What unique strategies are you looking at, and then is there any potential room for expansion where you're looking further? And I guess we'll start with you, Leo.
Okay, sure. Yeah. So like to reduce the cost, like basically you can run multiple provers on a single machine. So you can open as many containers as possible on your machine, and hopefully the resources like required by these containers, they are not competing with each other, and you can like design some smart scheduling algorithm on your machine, like to make it possible for these containers. They do not at least compete too much on the resources, and which means like it doesn't affect the performance requirement of your like ZK customer. So probably like just one tech part of like how you can like reduce the cost. And second, you can like attract as many GPU like servers from the community. So like record like previously like in either like Ethereum mining or like Filecoin mining, like there are like a lot of like idle GPUs like sitting there. You just want to, but these like GPUs they may not be like this like 4090 GPUs. They are like probably like 2080 or like 3070 something GPUs. Yeah, you just try to like deploy your like provers on this like probably like older version GPU and still making it like usable for the current like ZK projects. Yeah, so that's like just two ways to reduce the cost.
So we kind of look at this in like two ways. The first, probably more obvious one, is just incentivizing competition, right? Because that's basically how things get faster and better and cheaper. The second one is the fact that provers on our proof market don't really have to be like open source. They can literally be full proprietary, right? So what that lets us do is sort of monetize the ZK expertise of like the entire community, because as much expertise as our own team has, I'm confident that the wider ZK team probably has a lot more expertise, right? So you can run proprietary provers, you can invest into better hardware, run proprietary software, firmware, all of that, and you get to reap the benefits of that because you basically get redirected more revenue from the proof market essentially, right? So you can choose to customize whichever part of the stack you want. You can choose to focus your investments on whichever part of the stack you want. You can even choose to collaborate with others to build something like a well-rounded package. And you can sort of monetize that on the proof market without really having to like making it open source or anything. So yeah.
Okay. Again, I think we should look at the problem end to end. The naive solution is very straightforward. You source cheaper compute from the mining operators or whatever cheaper hardware GPUs you could get. But that's not quite interesting. I think we are taking the harder route. I call it ZK VM or proof system GPU co-design because I think the ZK VMs or the proof systems were not designed for the accelerators. So the current approach is that people implement ZK library on the CPUs. It takes whatever resource with whatever of parallelization implemented in their library, Rust library. And teams like us, we took their Rust library, trying to make it fast with GPUs or with ASICs. I don't think that's a sustainable approach to reach the peak performance, because from the mathematical level and from the system implementation or architecture level, it's not really accelerator friendly. It does not scale on the hardware accelerators when you got many like threads on the chip, as well as like fast compute on the chip. So the way we want to look at this is we should redesign the proof system or the ZKVM with accelerators as a first-class citizen. Like when you start to design at the math level or start to implement your Rust library, you should have accelerators in mind. I think this is an ultimate solution to drive the cost down, other than just looking at the like hardware cost. Again, another approach that down the bottom is actually to build cheaper ASIC. That's another approach to drive the cost down. But just competing on the hardware supply cost is not really interesting. It's also not a long-term solution. Thanks.
Yeah, I think you guys said it all already. Maybe just to add from our end, we are building a universal platform to be able to aggregate and support as many type of workloads or proof systems as possible, because we see that's one of the ways to increase hardware utilization And on the other side, it will boil down to decreased operational costs per proof, per minute or per hour, whatever way you look at it. And also the other thing is that to offer like a scalable network where, for example, you get a couple thousand nodes in your network at 80, 90% or 70, 80% network utilization. I'm just throwing in something that has sufficient redundancy to be able to support, let's say, one STAC proof falling in, which requires, let's say, 1,000 nodes for 10 minutes, because the proof tree construction of STAC is so high. So it's kind of, it at the end boils down to like decreasing the cost of proving, removing the idle time from the user, and like kind of efficient orchestration within our network, both at node level and at network level, so that we can support whatever software efficiencies or hardware efficiencies have been gained by co-design, etc., etc. We are building to support all this from our angle universally.
I like the variety of perspectives, focusing on the GPUs, focusing on hardware acceleration, focusing on the competition side of things, and then the like leveraging the specific scenario on what you're trying to prove, and then designing the structures specifically for that. I guess one thing that wasn't mentioned is potentially standards. And how do you see standards within the proof generation playing out? Do you see it as, a type of, we'll see what the best type of structure is, or should there be maybe some alignment on that going forward? Well, I guess we'll start with you, Norbert.
Yeah, so I'd leave the standardization of proof systems and those type of things to our bright guys here. I'd say from my angle, standardization in terms of the proving infrastructure, we've kicked off an initiative solution. It's really hard. If you can build a piece of software like similar to like MathBoost or something like that, but it's ZK Boost, that connects proof providers from one side and anyone demanding ZKPs from the other side, and lets them just express what they want and have all the options available through the software. I think that's going to be key in terms of UX for outsourcing proving, and that's the type of standardization we are looking at, and we are part of the consortium as well, supporting.
From our perspective, standardization definitely very important. However, took a different approach. We don't create a standard and trying to push it out. We took the other side of the approach, which is we try to integrate with them one by one and to figure out what the right standard is. So what's happening right now is that we have different ZK clusters. For example, elastic chain. All of the elastic chains from ZK Sync, they follow the same kind of standard. They have the same proving infra. On the other side, if you look at a scroll ecosystem, they have a different standard and proving infra. It's not clear yet if we can create the same standard and apply to different ZK clusters. But I think within each ecosystem, the standard can work across their own chains. The challenge is really how to enable the ZK clusters to collaborate with each other and create industry-wide standard. Yeah.
So I'm kind of on two minds about this. So as a proof market, obviously it's really good when things standardize because it's less work for me to integrate anything. And it also means that my market doesn't need a lot of hardware. It can just focus on like one specific hardware, right? So from the perspective of a market, standardization is obviously really good. But I'm not sure if we're ready for that as an ecosystem yet, mainly because of the speed at which things are moving, right? Like if you think the ecosystem has slowed down, you just have to go to one ZK summit to figure out like, hey, there's so much new research still coming out, so many new curves and all that still being discovered. And yeah, I'm not sure we're there as a space yet, to be honest.
Yeah, so like from Cysic's perspective, like we wish there was a standard so we can just focus on developing the best hardware for the standard, but there is not. Yeah, so like I guess like for all the like proving infra, we can have some positive effect on like how the community reach consensus on like which standard we or like which like the ZK system we can use. If we can have like fast enough and also cheap enough like ZK proving infra, and probably like there will be a chance that the project, the ZK project, they can like migrate to this like new probably like a standard or something.
Awesome. I think I was notified that we're a little bit over time. I was so engaged with the panel and the discussion. But I guess I'd like to welcome the audience to give a hand for our panel participants. And thank you all for coming.
Thanks.